everyone. Before we start our discussion, I think it's good to revise back our requirement of our project. I know some of you are still lacking information about our project. So firstly, as we all know, our project is a small scale wind turbine prototype for laboratory testing, and the project duration is 6 weeks, including material selection, fabrication, assembly, and testing process. The requirement of this project the blade must be lightweight enough to rotate at low wind speed, strong enough to maintain structural stability during testing, easy to fabricate within limited duration, and remain within our project budget of 200 ringgit. Now we need to decide which material we want to use in our project, either PVC pipe or fiberglass composite, because these two materials are suitable. However, I would like to hear your opinion on which material are more suitable. What do you think?
I see where you're coming from, Afham. Balancing our resources is our biggest problem here. So at the same time, I'd like us to consider the technical advantages of using fiberglass composite, since it's also within our budget. Research from Montana State University regarding fatigue strength material shows that the young modulus for fiberglass composite is much more higher than PVC. So it is much more stiffer and durable, which will maintain the shape if the wind hit our blade. By using fiberglass, we could benefit from the reduce of blade flutter, which will make our blade much more stable. So it will prevent excessive vibrations that will affect our functionality of our wind turbine blade. Fiberglass also can maintain a consistent airfoil shape. As we all know, PVC is made from thermoplastic, so it can lose its pitch angle under a higher stress or higher force. So I know PVC is much faster to work with, but I think we should consider using fiberglass too. So how do you guys think about it?
I agree and understand your point about structural stiffness and aerodynamic consistency. You are correct about the fiberglass can perform better and improve blade stability during testing. However, I think we should also consider whether the additional performance increase the fabrication complexity. Based on my study, PVC blades are commonly used because they are lightweight, inexpensive, and easier to fabricate. Let me give you some information. PVC fabrication mainly requires simple procedure, but fiberglass fabrication requires a lot of procedure and safety precaution. And you also need to realize cost is also important, because PVC material may cost approximately 20 ringgit to 40 ringgit, while fiberglass with other accessories may exceed 100 ringgit. Since our total project budget is only 200 ringgit, I think PVC provides better overall visibility. And we also need to consider other expenses besides material cost alone. Ben, are you agree with that?
I understand there is concern regarding structural performance, and I agree that fiberglass provide better stiffness compared to PVC. However, from the fabrication perspective, I still support PVC because of manufacturing efficiency is more important for our project timeline. PVC offers several practical advantages, such as already have a better geometrical, easier cutting process, lightweight structure, and the most important things is lower fabrication time. For example, based on the article that I found in the internet, PVC wind turbine blade by REUK, the several prototype tutorials show that PVC wind turbine blades can be fabricated fabricate within a few hours by using simple tools such as hacksaws and drill. Meanwhile, fiberglass fabrication require layering fiberglass sheet, resin application, curing times, sanding, and finishing processes. Although fiberglass provide better mechanical properties compared to PVC, but for the fabrication process, I think that it takes much more time consuming. I agree with Dani that PVC has limitation. PVC is more flexible compared to fiberglass, so excessive bending may occur under higher loading conditions. However, since our testing condition involve controlled airflow and low airspeed testing operation, so I think that limitation remain acceptable, right guys?
I understand regarding your point, Bill, that fabrication simplicity, and I agree that PVC is more suitable for our project manufacturing wind turbine blade. But if we talk about performance perspective, I think fiberglass is better because of blade material effects, such as rotational stability, aerodynamic consistency, and also efficiency performance. Fiberglass maintains blade profile more effectively during rotation because of higher stiffness. PVC blades are lightweight, which can help rotation startup at lower wind speed. However, if the blade bends excessively, airflow consistency may decrease and also may affect performance accuracy. So I agree that fiberglass increases cost and also fabrication difficulty. But from testing quality perspective, fiberglass is more stronger in engineering justification. How about you, Arif?
That's a great opinion, Judge, regarding performance quality. And I also agree with you, Dani, that fiberglass provide better structural performance. However, I think engineering decisions should also consider feasibility, budget, fabrication capability, and project objective. According to prototype wind turbine references that I take from the website Renewable Energy, PVC is widely used in educational and laboratory scale projects because it is inexpensive and accessible. For example, PVC fabrication can be completed using a basic workshop equipment, while fiberglass requires additional material and handling procedures such as mold preparation, resin, and others. What about cost? Like Afham said, in terms of cost comparison, PVC pipes blades may only require around 20 ringgit to 40 ringgit, but fiberglass may exceed 100 to 250 ringgit. That means fiberglass fabrication can consume almost 50% to 75% of our total budget, which is 200 ringgit. While PVC only use around 10% to 20%. We need to remember that we also need to cover other components using our project budget, such as shaft and motor. So the key question is not which material performs best theoretically. Instead, the question should be which material provides sufficient performance while remaining achievable within our 200 budget and project timeline. From that perspective, I think PVC provides a more balanced engineering solution.
Thank you for your concern, Arif, regarding feasibility. But in aerodynamics or fluid mechanics, angle of attack is very important for the blade. Even the slightest changes in angle can affect our rotation, the physics rotation of our wind turbine blade. So what's your thought on the balancing?
Okay, I hear your concern about balancing. So the balancing is about performance, cost, manufacturability, and project requirements. So the best solution is not always the highest performing material. It is the material that the best satisfies the project constraints. So about the angle of attack, you're absolutely right. Even a small blade deflection can change the angle and affect the aerodynamic behavior. When the angle of attack changes, the lift and drag force also change, which can reduce the accuracy of our experimental results. That's why if we choose PVC, we should think about ways to reduce the blade deformation, such as using a thicker blade section, adding a support reinforcement, or limiting the operating wind speed during testing to improving the balancing.
Yeah, I understand with that, and also I agree with that. But if blade deformation affects airflow consistency, our testing result may become less reliable.
That's reject. But based on my studies about small scale PVC by Huzaifah, I think that acceptable structural behavior and rotational performance can still be achieved under the lower speed testing conditions.
I agree with both sides, either fiberglass or PVC. I know fiberglass clearly provides better structure and aerodynamic performance than I said before. However, when we looking back to our budget, just 200 ringgit, fabrication time just in 6 weeks, manufacturing capability, I believe PVC provides the most practical overall solution for our prototype. After hearing all your opinion, first, fiberglass have better stiffness and more stable aerodynamic performance, but higher fabrication complexity and cost. Second, PVC, lightweight, lower cost, easier and faster fabrication, and acceptable testing performance under controlled condition. Therefore, our discussion can conclude that PVC is more suitable material for our wind turbine prototype, right? Because it better satisfies our project requirement, budget limitation, and fabrication capability. Does everyone agree with that?
I'm happy with the choices of PVC. It's worth noting that fiberglass is still keep us under 200 ringgit at roughly 100 to 150. But by using PVC, we can reallocate those funds towards a better sensor or general.
Yeah, I agree with you, Afham. Fiberglass offers better stiffness, but PVC remains acceptable for our testing scope.
I like your idea, Jad, because PVC improve fabrication efficiency significantly.
I also agree with you guys. For me, from the start, PVC provide the best balance between functionality, feasibility, and cost.
Okay, everyone, for the